It starts here. Metal so hot that it flows like water. A specific recipe, die cast under huge pressure into precision parts. And raw steel forged into rough shapes, and then meticulously machined to perfection. And it comes together here, taking those parts and assembling the engines in the best possible way with the most dedicated workers and the latest technologies. Whether it's the air-cooled 45-degree V-twins built for the XV platform, or the liquid-cooled 72-degree V-twins built for the Loki platform, an engine is only as good as the sum of its parts. And year by year, Buell engines have just kept getting better. This video will show you how the world-class features and benefits of every Buell engine have grown out of the same core philosophy. First up, the deep, pulsing torque of the XV's V-twin. It has evolved into a fully modern and unique power plant as the result of thousands of hours and hundreds of thousands of miles of testing, development, and engineering, both in extreme real-world conditions and in high-stress racing environments.
By using racing, testing racing as part of the development process prior to launching a bike. And very early in the process, we actually redesign components in the engine and make it a better engine for the street guy.
One of the big differences between a Buell customer and a Harley customer, a Buell customer winds a bike up more. They're spending more time at higher RPM as opposed to low RPM cruising. And that led to the oiling system that initially debuted on the XBRR race bikes and then migrated to the XB production engines in 2008 and newer.
All XB engines are produced at the Capital Drive powertrain plant in Milwaukee.
Operations we have at Capital Drive, in addition to assembly and test, we have all our core competency machining operations. For our aluminum machining, we take castings as they come in from our supplier and we machine crankcases, cylinders, cylinder heads. We machine those components complete from casting when they arrive. We powder coat those components in-house as well. In addition to that, we make some components that you might not think we'd make in-house. We make our electrical components, our rotors and our stators. On the steel side, we take raw forgings for camshafts, our flywheels, and our connecting rods. We machine and heat treat those in addition to our transmission gears. All that's completely done ready for assembly as well. Let's talk about the XB engine in comparison to the Sportster engine. Years ago, early years in Buell, it was a Sportster engine with some different cosmetics and a few performance tricks that we installed in that on the assembly line here and then shipped to Buell. Over the years, the XB product, the Buell product has differentiated. Now we have made that more performance driven, and as that's differentiated, we have tuned that to Buell specifically, where it is its own specific crankcase. It has its own components, high performance head, high performance cams. It has become less Sportster, more Buell specific.
Buell's quest for an ever-better sport bike engine is served by a clever design philosophy. Make parts multifunctional. This cuts costs and unnecessary weight, both good things for the consumer. Like this example, it's the cam cover on one side and the oil pump on the other. The lower weight is good for sport bike handling and acceleration. Plus, Buell's compact control flow dry sump lubrication system offers an added benefit in extreme riding conditions, like an 8-hour endurance race at Daytona. Compared to a wet sump design, it's less likely to uncover and pull unwanted air into the system instead of oil.
Well, it's Daytona, man. It's 8 hours at Daytona, and this place eats engines, but we've never failed an engine here at Daytona in the 8-hour race, so these things are pretty solid.
One of the other things that really sets our engine apart is the control system. The fuel injection system on the Buells was developed in-house. It's a great system. It gives you really nice, clean emissions. Every one of our air-cooled engines is EPA and CARB compliant without a catalytic converter. But they still make great power up top. We have injectors that have a very aggressive skewed spray. They were developed just for the XB. It was actually the most heavy skew that the injector manufacturer had ever done. And because of that, it went to a unique injector for the front and rear, again, to squeeze every last little bit of power and performance, as well as excellent fuel economy out of the bike. So you can run them hard, you can run them slow. Doesn't matter how you drive them. Altitude, temperature, you name it. It's going to fire right up and run well.
Compared to the predictable power of the torquey XB, high-revving inline fours can sometimes get their riders into trouble. If a rider is leaned over in a corner at the transition point between soft and full power, it takes a very small increase in throttle to get a big change in horsepower, and this can sometimes lead to a terrible result. Riding the XB is a very different experience. The air-cooled XB engine is at the pinnacle of its development with more than 100 horsepower at the crank. Of course, no engine is developed in a vacuum. All along the way, Buell engineers applied the trilogy of tech to improve the chassis and suspension. So, when the time came to deliver a machine to those sport bike consumers who wanted even more performance, Buell was ready when it went wet in 2008 with the all-new 146 horsepower Helicon engine.
Helicon is a big torque engine, and the torque will get you around the track quicker.
To help bring this all-new engine to life, Buell turned to Rotax, the Austrian company that had been providing powerful performance twins to the sport bike market for years.
This is the first version of the Helicon 72-degree V-twin. We're getting experience with it in racing. We're doing a lot with it, performance development. We're getting results on the racetrack from it. Now with that, we're feeding all of that development and learnings we're getting on the racetrack back into the production engine, the development of it, and the life cycle of the engine.
Buell engineers spec'd out what they were looking for from this engine and then teamed with their Rotax counterparts, remaining closely involved from the earliest design and development phases right through to today. The Helicon engine grew to be completely original for lots of good reasons.
There's a number of big picture things in the architecture that we spec'd on this bike. Things like a 72-degree V angle. You might ask, well, that's kind of a strange number to come up with. Why would we do that? There's a couple reasons for that. One of them being that the compact V angle allows us to push the engine forward in the bike and get the mass centralization where we want it. The weight distribution is optimal for what we feel a rider needs. Another reason for doing the 72-degree V-twin is so we can get straight intake tracks, allowing the air to come straight into the combustion chamber of the engine. This is a very important thing for performance development. The more air you can get into the cylinders, the better that it flows, the more fuel you'll be able to burn, the more power the engine will output.
Since every part of this engine was drawn from scratch, each one had to be revisited as the engine grew into a complete system. And so there's a lot of smart thought that has gone into every little part, like this cam-following rocker that actuates the valves. They worked through 5 good prototypes until they settled on this final design made of tool-grade steel.
Another pretty important thing performance-wise on this engine are the balance shafts. Now that allows us to do a couple of things. One thing that allows us to do is solid mount the engine to the chassis. So that's a big benefit for chassis stiffness. And there's going to be less vibration to the rider interface points. It's going to make you more comfortable when you're riding the bike. Another big part of making this bike easy to ride is the hydraulic vacuum assist clutch, which has a slipper action functionality. So what this means is as you come into the corner and you downshift, it'll allow the clutch to slip. It'll keep your rear wheel from hopping and keep the chassis of the bike settled as you set up for corner entry.
The Helicon engine is the right design for today's high-performance sport bike customer. Buell engineers have created highly sophisticated street test packages called duty cycles that give accurate results.
the engine is the heart of the motorcycle. The engine has all kinds of responses to the way that you ride the motorcycle. So whether you're talking about, environment, heat or corrosion, or high RPM usage, loading, different loading, even surface content, we have found out over the years, really affects the way that an engine behaves. And we were able to create a duty cycle to get a real sense of how it is that extreme riders use our motorcycles, both domestically and in Europe. You have to get it down to a manageable set of ingredients that you can run a motorcycle through and you can run components through in order to guarantee that in all these different environments, for all these different rider types, it'll work.
This motor is going to make you a better rider. It's going to make you a faster rider on the track. With the flat torque curve that it has, it's going to be really controllable, really easy to ride. You're going to get up to speed quickly with the motor. So one of the advantages of the twin is the big torque that it'll produce.
And this is the core message. Because of how the engines work, Buells are truly easier to ride at sporting or race speeds than many competitive models. It's true for the XB. And it's true for the Helicon. Of course, the process of getting the machines to that point is the result of a lot of challenging work.
When the Helicon motor came out, right after launch of a brand new motorcycle, brand new engine, blah, 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 we went racing with it and had great success. But that's because we race tested it before anybody ever saw it. So that's what we're doing with the engines, is we stretch them further and then we pull that back down and we just keep pulling the actual production level of motor up as we learn where it can go to. So the Helicon motor, that's the first year for it. Has it got a lot of potential beyond that? Yeah. Are we going to roll it out instantly? No. We're going to roll it out when it's ready, when it's tested.
We're constantly learning. We're learning on the racetrack. We're learning from feedback from the field. We're constantly working on improving this motor. So we know the competition is doing the same thing. We've got lots of great things to come in the future.